mode. There we go. All right,
All
we are
righty.
live.
Welcome, everybody. It's now on the hour, and we start, as we always do, with a round table, as I'll ask everybody on board here to tell us where you are and what's in the sky that you've seen this week, or tell me the weather, whichever is more interesting. So we'll start with you, Rob.
Sure. So I haven't met all of you yet, but my name is Rob. I'm I'm a Jesuit regent. I'm the new outreach officer for the Vatican Observatory in Tucson. And so I'm looking forward to kind of meeting up with you guys on a monthly basis and working with you. And anyway, Larry and I broke out the telescope to watch the eclipse last night, the lunar eclipse, which was really fun. And then on Saturday night, I was up in Phoenix, and some of the Jesuits up there, we set up a telescope in the backyard, and we were looking at Saturn for a little while. And I think that's the first time I've ever seen Titan in a telescope. So that was kind of a cool thing for me.
Excellent. Bob Tremblay, where are you? What's the weather?
I am in Clinton Township, Michigan, northern Burbia, Detroit, and the weather is gorgeous. My wife and I went for a walk this morning, and I'll probably go for a bike ride this afternoon. And I've seen the moon in the sky. Almost broke my telescope out, but didn't. And we're going to an event this weekend, and hopefully the sky will be clear both Friday and Saturday. There's this giant event. I put it in chat this weekend here in southeastern Michigan.
Okay, Jim Wren.
Good morning, everyone. In Anthem, Arizona, just north of downtown Phoenix. And for something interesting is the weather. Yesterday, for the first time in 113 days, the high temperature was below 100 degrees.
Wow.
So I'm not complaining.
One hopes that's Fahrenheit, not Celsius.
Yeah, Fahrenheit. I'm not complaining. You know, my wife and I have been here 22 years, and we're very happy. But just something interesting to take.
Right, Margaret.
Well, I'm fairly close to Bob, so the weather is pretty much the same. And I wandered out a few times last night to stare at the moon, but other than that, I haven't been doing a heck of a lot. Staying up late, working on the house, whatnot.
Okay, Larry. You're muted. Well, you're still muted, but on the other hand, we know that you and Rob were seeing the same things, so we kind of get the impression of what the weather in Tucson.
Can you hear me now?
Yes, yes.
I'm getting some weird, strange background, and I wonder if it's one of the links that Bob Tremblay sent. But I'm here in Tucson, not very far from where Rob is, and weather is about the same. And I'm trying to figure out where I'm getting this strange background music from.
Not it.
Right. Okay, Joel.
Yes, down here in Green Valley, we too have finally gotten into the high 90s, and I have had a wonderful opportunity last couple of nights to see the eclipse. And on our International Lunar Observing Night, I actually took a couple of images with the 10-inch Meade, and wasn't anything to write home about, but it was a wonderful evening.
Great. Chris Kennedy.
I am in New York City, so the only interesting thing in the skies are jets going into LaGuardia. The weather, though, is delightful, 70 degrees, beautiful fall day.
Elizabeth.
Good morning. I'm a housewife from Torrance, California, and we're near the beach cities. And I was just very interested. I'm interested in everything in space, and I'm especially interested in black holes. And it's typical. The gravitational pull just pulls me in. There's something spiritual about it. And the weather
what's
here.
What's the weather like where you are?
Pardon me?
What's the weather like?
Warming up now. Yesterday it was quite cool. And but now, and of course, a few days ago, we were in 90-degree weather, which was unusual for us. But it's lovely here. So I'm happy to be here.
Excellent. Dennis.
Jesuit.
Fabulous. Thanks, Elizabeth. Dennis.
I'm in Denver, Colorado. It's cooling off here. It's 50s overnight and 80s during the day. Beautiful, clear skies today. But in the mountains last week, they reported the first snow of the season.
Ooh. Okay, Tom Toll.
Hi, folks. Tom Cole, north of Philadelphia. Sky is overcast. It's supposed to be rainy later today. But it's been nice for the past several nights, which is good. I think we should have a battle of the warring T-shirts here, given that Father had on his Loyola one and I've got on the BC one. That's all.
Excellent. Okay, Linda, who's showing us your Pennsylvania shirt.
Well, it's the Phillies. Go Phillies.
Right.
We had a lot of clouds today, so we weren't really able to see the lunar eclipse. It's about 70 degrees with a little bit of rain.
Okay, Gary.
Very clear here in Milwaukee, Wisconsin, and last night I was able to watch the eclipse.
Fabulous. Fernando. So happy to have a couple of your friends here a couple of days ago.
Yes, and you have another one there too.
Hello, Fernando.
All right.
Yeah, well, so greetings from Munich, Germany. It's a wonderful afternoon in the end. Not much to see in the sky in the last, I don't know how many days. It's been cloudy and raining all the time. And yeah, the temperature is 19 degrees, but Celsius.
Right. Okay, Phil.
I'm Phil Smith. I live in Eastern North Carolina, New Bern. And last night I got to go outside, see the moon rise, got my binoculars out, looked at it, went back out later, and it was total overcast, could not even see a bright spot in the sky. So, but tonight I hope to go out on my kayak and watch the moon rise over the river. That's always a spiritual event.
Well, except not an eclipse.
No.
Richard Sum.
It's 87 degrees here in Corpus Christi, Texas. And I've been delving into the NASA small body database, and they've got 150,000 asteroids, one of which is named after Brother Guy. At least there's one. And it's interesting, there's about 20,000 of them that have rotation and diameter. And with that data, I've been kind of just basic velocity, acceleration, even the jerk, and it seemed to correlate around a acceleration of 10 to the minus seventh centimeters per second squared. And it's like, is that, they've been out there for billions of years, maybe is that an indication of some kind of universal phenomenon? That's the question, I guess.
Yes, there is. There's actually a spin up due to something called the Yorp effect, which tends to spin small bodies up to a rate at which they start to fly apart, where the surface gravity is matched by the essentially centrifugal force.
Yeah,
and that's why you get these top-shaped asteroids.
But that's a rotation of 2 days. If the rotation...
No. About 2 hours.
2 hours. I'm sorry, 2 hours. Yes.
Yeah, right.
But most of them are spending about 8 hours or so. So
that's true. That's true. A lot of them are, and I'm sure there's a good explanation behind it. So rather than pretend I know, I'm just going to move on.
Okay.
It's a great question.
Okay.
There are people who actually do that kind of stuff, and I could point you to their names.
I appreciate that.
Right. Carmen.
Well, I am in Uruguay, South America. We are entering spring, and yesterday there was a beautiful sunny day with 25 centigrades, and I was so excited of everything I was going to watch, but then it was a complete overcast, and we could only see clouds.
Okay. Justin
Golden in Watertown, Connecticut, 68 degrees. Last evening was beautiful, clear sky, and really enjoyed it.
Patrick.
I'm very delighted to be invited to this meeting. And last night, what my wife and I did at midnight, we went out. It had rained all afternoon, and it started to clear up. We saw the moon, but on our patio, on the back patio, we saw the reflection in puddles of the moon, and we had never seen that before, and we're totally delighted.
Wonderful. Where are you?
I'm in very close to Mexico City. That's where I've been living for the last 52 years.
Okay, fabulous. Alfred. Up, you muted.
Sorry. Took me a while to find the unmute button. I am south of Minneapolis in a southern suburb, Apple Valley, and was 75 at the beginning of the of the Zoom, but heading for the mid 80s. And last night was very unusual in that there was no cloud cover during an astronomical phenomenon.
Welcome to the Midwest. Yes.
It was very clear, and I even played around with my camera.
Excellent. Mark.
Well, hi, I'm Mark Dorian. I'm ringing from Edinburgh, Scotland. It is a sweltering 18 degrees here today, which is the highest temperature it's ever recorded, apparently, no joking, on the 18th of September. So 64 Fahrenheit, that is. Best thing I've seen in the sky recently is the moon last night. We just saw it out of the mist, the sort of Sherlock Holmes mist, which was covering it at the time, and it just appeared absolutely massive. So fantastic.
Fabulous. Thomas.
Oh, hello, everyone. I'm teaching now, so I'll be quick. And I just saw it this morning. I had to take my son to the airport, so I went to bed early. So it was beautiful. Kind of, I like that Sherlock Holmes. That's what it looked like for me, that kind of misty thing. I'm from
Where are you?
Tottenham, Ontario, north of Toronto.
Okay, great. Celia?
Hello. Hi, I'm Celia. I'm at the Mass General Hospital Cancer Center here in Boston, Massachusetts. And my dog and I saw the moon this morning as we were out at our 4:30 a.m. Jaunt, and it was absolutely gorgeous.
Fantastic. And Claude?
Yeah, hello from downtown Ottawa, 24 degrees Celsius, and I participated in the International Observe the Moon Night a few nights ago, and of course I caught part of the eclipse last night.
Okay. William?
Yes, this is William Gabriel. I live near downtown Fort Worth, Texas, the better half of the DFW Metroplex. And I've got a question for you. We're near TCU and near the Bonnick Meteorite Gallery, which has the world's second largest collection of meteorites. But on my bucket list is to visit the Vatican Observatory. And I imagine you have miles and miles of shelves with meteorites on them. How would you describe your collection there?
We're about number 20. We're not nearly where the mounted collection is, but we do have some on display in our visitor center, but we've had so many people coming to try to visit that we are actually limiting who gets to come into the observatory itself, which is kind of a shame.
Yeah.
But otherwise we'd be doing tourism the entire time.
Yeah, because that's on my bucket list to visit that one day.
On the other hand, since you're a Sacred Space member, maybe we could bend a rule or so.
I just want to see the meteorites.
Right. Pamela, where are you? Oh, you're muted. So you're still muted. You're in Phoenix. And so I guess it's not all that different from what Jim was saying. So wave to the camera, we'll move on. Okay. David's apostrophe. You're muted and we can't see you, but.
Yeah, I'm driving south on 95 near Fredericksburg, driving through rain.
rain. It's about 70 degrees.
Okay. Well, drive safely and don't listen to us. And finally, is there anybody I've missed? I think I've got everybody. And now I'll turn it over to Paul Gabor, who was here. I can't find him at the moment, but I'm assuming you know where you are. All right, Paul, tell us what's the latest news at the VAT?
Well, the season hasn't really started yet. The observing season, that is, the monsoon season, that is still going on, sort of. So we had hopefully the last little thunderstorm this weekend on the mountain, this past weekend, and I sincerely hope that that won't continue. At least I'm going up with Mark Trueblood and Robert Crawford, whom Larry Lebowski knows very well, on Friday. So hopefully things will go well. This is mostly a technical thing. We'll be trying to use a new technique that Robert developed for collimation of the telescope. It's called donut. So we'll have some dough and we'll put it on all over the telescope. And no, that's not. Okay.
Enjoy the nuts.
There's plenty of nuts around. So yeah, and with the plan basically is that Richard Boyle will come to overlap with me a little bit, and he'll stay at the telescope for basically a week. So let's hope that this is really the beginning of the observing season for us now.
He usually brings good weather with him, so.
Yeah, he was supposed to arrive last night, but I'm not quite sure what happened. But he probably missed his connecting flight.
Yeah.
Anyway.
Okay.
It's good to see everybody, and hopefully you'll have a nice chat today.
Okay, well, thank you everybody for being here. Now I'd like to turn this over to our guest. And I would first start by asking you, how do you pronounce your name? Which is probably sounds that we non-native speakers can't handle. And then how should we pronounce your name?
So my first name is pronounced as Ewine.
Ewine.
And the last name is van Dishoeck. So you separate the S and the H.
So it's not Dish, but
not Dishoeck
but
or something like that, but Dishoeck.
Dishoeck, okay. And what is your current job right now? What is your day job?
My day job is still being a professor at the University of Leiden in the Netherlands. I'm also associated with the Max Planck Institute for Extraterrestrial Physics in Garching in Germany, where I spent a fraction of my time.
And you've been an astronomer for how many? I don't dare ask, but for a while.
For a while, absolutely, but not from the very beginning.
Interesting. So how did you get into astronomy? This is always always a great, how did I get here story.
Yes. So I actually started studying chemistry because, as it goes, in high school, I had a very good chemistry teacher.
Where high school being where? Where was this?
High school was actually in the Netherlands, in Leiden, the Netherlands. Although I should say that I got my first science interest when I went to San Diego for half a year when I was just 13 years old, and for half a year when my father was being on sabbatical there. And my parents put me in a junior high school, a public junior high school. And that was my first introduction to science. I had a wonderful science teacher there, actually a female Black teacher, which at the time, 1968, was quite unusual. Because I had only had Latin and Greek in the Netherlands, I was in a grammar school.
Right.
So
were your parents academics then?
My father was, but all in the medical world. So my whole family was in the medical world. My mother was a elementary school teacher.
Okay.
Yeah.
So you're.
So I had an excellent chemistry teacher, a poor physics teacher, and so I started studying chemistry, and I loved it. And I dived deep into theoretical chemistry, quantum chemistry. And I was sure I was going to continue in that for my PhD after my master. But then the professor in theoretical chemistry died, and as it goes in universities, it was clear that it was going to be a long time before there was going to be a successor. So they basically told me, well, you better start looking somewhere else. And so it was my then boyfriend and now husband, Tim de Zeeuw, who actually was studying astronomy, and he had just had a lecture on interstellar medium in which there were molecules. And so he said, gosh, isn't that something for you? And so one thing led to another. They introduced me to the world expert on astrochemistry, on molecules in space. That was Professor Delgarno at Harvard University. And so I went to Harvard for half a year in between my master and my PhD, because at that time already nobody wanted to give money for interdisciplinary work. So astronomy said, oh, very nice, but too much chemistry. Chemistry said, well, very nice, but too much astronomy. So in the end, they were able to find a position for me in the Netherlands to do my PhD there.
So who is your advisor?
So Delgarno was actually one of my advisors, and Harm Habing was my other advisor. Yeah.
So after you get this degree in astrochemistry, what was your career path from there?
Yes, so I was fortunate to go back then to Harvard on a junior fellowship of the Harvard Society of Fellows, which gives you a lot of freedom to do what you want. And that was also the period that I started to basically get more and more into astronomy. So my first 2 years of my PhD was still very much quantum mechanics and quantum chemistry, but then I went on my first observing trip to La Silla in Chile and got to do my own observations, and that was a fantastic experience.
So this would have been in the 80s?
Yeah, early 80s, 1982.
Okay.
And then I got sort of my taste of observations, and so it was really during my postdoc period that I started to transform more and more from a chemist to an astronomer. So after that, I went to Princeton for a year on a visiting professorship at Princeton University. And then I got my first faculty offer in Caltech, actually, in the Division of Geology and Planetary Science, yet another aspect of interdisciplinarity. They had just started a program on cosmochemistry. And so they were interested in also having astrochemists there. And that was sort of my first
was that when Jerry Wasserberg was there?
Yeah, he was the one who hired me, actually. Yes. Very colorful.
Very colorful fellow.
Yeah.
Certainly, I know him mostly from the meteorite world.
Yeah. Well, of course, I got completely immersed in the meteorite world there as well. Yeah.
And for that matter, of course, at Harvard, the person I was a postdoc with was Al Cameron, who did asked a lot of this.
Yeah.
He was the fellow who worked out a lot of the theory of nucleosynthesis.
Absolutely.
How various isotopes were made inside stars.
Right. And then also had theories of how they then entered into the solar system.
Right.
Yeah.
So you're at Caltech in the planetary science division.
Yeah.
Probably with a lot of people I know.
Yeah.
Ed Stolper would have been there then?
Yeah, exactly.
Right.
Yeah.
And why did you ever leave? That would seem to be a dream position.
It was, I loved Caltech, and there was so much that I learned there also in observations. By that time, millimeter astronomy had started to develop, and there were these telescopes, the Caltech Submillimeter Observatory at Hawaii. And so my research shifted sort of from optical ultraviolet astronomy to millimeter astronomy, and especially to be able to look not at the diffuse interstellar gas, but more at the material, the dense clouds that ultimately make stars and planetary systems.
So at some point you wound up becoming an observer, not just a quantum theorist.
It's not just a quantum theorist. I always kept my foot in the chemistry, either through quantum calculations or through laboratory experiments. Although much not so much hands-on anymore. But so there's always been that interaction, but it was clear that new observations were driving the field. So my reason for going back then to the Netherlands was basically the two-body problem. We got offers for 2 very good offers in the Netherlands.
Right. For those of you who are not astronomers, the two-body problem refers to trying to find jobs for both a husband and a wife.
And so we got very good positions in Leiden. And there was another fact, and that was that Europe was about to launch the Infrared Space Observatory. So the first small satellite above the Earth's atmosphere that could actually do spectroscopy in the infrared part of the spectrum, where molecules have their vibrational modes and you can actually see them. And so they lured me and say, oh, you can get some guaranteed time on this telescope. And that was sort of another reason for going back. But certainly, I mean, I always, Caltech has always been one of my favorite places to be.
Well, was it odd to go back to being an astronomer at a place not only where you'd been an undergraduate, but also where you'd grown up? You were going home again.
Yes. I wouldn't say it's weird, but it's. I think it felt at home. I knew all the strong aspects of the university there, and especially the quality of the students, which in the Netherlands and especially in Leiden, the PhD students are at the very highest level, and I very much enjoy working with young people, and I knew that there I would be able to attract very good students.
Of course, that was where Bart Bach and Gerard Kuiper had studied a few years before you and me.
Yes, I've been fortunate to have known Bart Bach still, but, but yeah. Yeah,
Kuiper died 2 years before I showed up at Arizona, so I never connected.
Yeah.
We're that close.
Yeah.
So I think maybe Larry, did you ever meet Kuiper? Larry Lebowski?
They're not drilling at the moment. Yes, I had met Kuiper once or twice. Some of them in not the best situations because we were just agreeing with him on a discovery, but that's another story.
Kuiper was such an easygoing, nice, gentle, never controversial figure. And if you believe that, I've got this bridge.
Which one are we talking about? Yes. Yes. So yeah, I met him.
He started the Lunar Planetary.
Yes. Indeed. So you're back in Leiden. Now, at this point, what are the questions that drive you?
Yes. At this point now, or at that point then?
At that point then.
At that point then, well, for that really, Caltech was transformational, and especially the discussions we had with Dave Stevenson in the geology and planetary science.
Right. Another giant.
Another giant.
In more ways than one.
Yes.
Very, very large fellow.
So I was there. The other appointment in cosmochemistry was Jeff Blake, and basically, we were realizing that we would get, not immediately, but in the next 20 years, the facilities to be able to zoom in on planetary systems information. And we know that was not going to be a 1 or 2 year program. We had to start at a larger scale, sort of at the cloud scale and at the collapsing envelope scale. And that is where the single dish sub-millimeter telescopes were critical. But also at that time, the early 90s, is when ALMA started to be planned. And we knew that ALMA was going to be the machine for us in order to zoom into.
For those here who aren't familiar with ALMA, remind them.
Yeah, it's the Atacama Large Millimeter Array. So it's a collection of 66 antennas, so now radio antennas, but working at millimeter wavelength, so microwave, at a high site in Chile, just at the border between Argentina, Bolivia, and Chile. That's sort of tri-country point near San Pedro de Atacama. And it was finally started operation in 2012. And it's now doing fantastic work in the area of planet-forming disks, disks in which planet formation takes place. But at that time, we were sort of working towards that goal.
I remember as a student being taught how planets were formed on the basis of what we knew of planetary systems, which was ours, period. And you always wondered how much these theories were going to be turned out to be true. One thing that everybody knew about planets was that there would be rocky planets close to the star and big gas giants far away from the star. And of course, we found that's only true in our solar system.
Yeah.
But the other thing that everybody would talk about was the idea that there would be these disks of gas and dust. What did it feel like the first time you actually saw one of those disks, looking not all that different from what we had thought?
Yeah, no, absolutely. I remember that so well in 1995 when the Hubble images came of the proplets, as they were called. Not so much the ones that were bright, but the shadowed ones where you could see the disk. And see that it was the size of our solar system. And then also with the then available millimeter facilities, we're able to measure the mass and say, okay, this could make a planetary system like our own. So that was 1995, 96, the same year in which the exoplanets were discovered. It was an incredibly exciting year.
So this is what now happening. You're back in Leiden. You're doing these measurements. You're still using millimeter telescopes?
Yes, ALMA mostly, yeah.
All right. How has the question changed in the last 15 years?
Yeah. So it was a busy period in the 1990s because, of course, ALMA was being planned and developed. But then also there was this talk of this new space telescope, which ultimately became the James Webb Space Telescope. And we had just come out of this ISO satellite. And I recall very vividly a meeting that we had in 1997 talking about the results. And there were people from the US there working on Webb, and they saw all these mid-infrared results. And they said, wow, we really need to have a mid-infrared instrument on JWST. And so we started to team up between the Europeans and the Americans, the US, a small group, quietly but very, consistently pushing with NASA and with ESA that Webb should not only have a near-infrared camera and spectrometer, but should also have a mid-infrared camera and spectrometer.
No, what are the different wavelengths we're talking about? The difference between near and mid?
Yeah, so near infrared is 1 to 5 microns, and MIRI is 5 to 28 microns.
Okay, visible light is about 0.3 to 0.9.
Yes. So this is basically when you put on an infrared camera, and everybody knows these. When you take an infrared image of yourself, then you see yourself glowing. We're looking at heat radiation there.
So I know the answer, but just in case people don't know, why couldn't you just build one of those here on Earth?
Well, we can, but we can see only very tiny regions between the Earth's atmosphere, because the Earth's atmosphere is full of water, it's full of CO2, and those two molecules basically cover the entire infrared range. And whereas you can do some parts of that window from the ground, and some of the telescopes are doing that, both on the northern and the southern hemisphere, but you really have to go to space to be completely free of the atmosphere, and it's just unparalleled.
So with these telescopes, what is the question that drives your science today?
Yeah, so with ALMA, basically, we were able to zoom in on planetary construction sites in the outer disk. And as you said already, that is where the giant planets like Jupiter are forming. In fact, we think that was Dave Stevenson even who proposed that a Jupiter-like planet would form right at the ice line, the snow line, where water goes from ice to gaseous form, because that's where you collect a lot of material that you can build a core that can attract quick enough that you can attract the gas and make a gas giant. So with ALMA, we are studying these outer colder regions. Webb, on the other hand, is sensing the mid-infrared radiation, and that's the vibrational modes, and those are much higher energy. So we're looking at the warm gas, the hotter gas, and that is coming from the inner few astronomical units. So terrestrial planet formation, basically, the part of the disk that ALMA is not able to see. So they are very complementary, and we're trying to sort of look now at both the giant planet construction site and the terrestrial planet construction site.
So you are part of one of several different teams that work with the James Webb Space Telescope. Explain how that works. Just the how do you organize scientists who are all interested in the same thing to do a separate kind of work? You're part of the JWST team.
Right. Yeah.
Tell me what that stands for and how that got started.
So that's JWST Observations of Young Protostars, and
JOYS.
Yes,
yeah.
Joyce. This one actually came out of the fact that after pushing NASA and ESA, we were able to allowed to build the MIRI instrument, the mid-infrared instrument. And so I became part of the consortium, the European. It was a 50-50 partnership between Europe and the US. And I became part, the US provided the detectors and the cooling, and Europe basically built the whole optical bench, the instrument. And we as the Netherlands became made part of that, the spectrometer main optics. So we really wanted to build the spectrometer. And so I was the co-principal investigator for the Netherlands in this consortium of about 10 European institutes. And what you then get as reward for your investment of 15, 20 years into this instrument, because we built our part of the spectrometer between 2002 and 2008.
And it didn't launch until...
Oh, it didn't launch until 2021.
Yeah.
So we delivered it to the UK. The UK was leading it and integrated. We delivered our instrument to NASA in 2012. And then it was indeed finally launched in 2021. So as a reward for all the investments that you then make in such an instrument, you get a certain amount of guaranteed time. And we decided as the European consortium to put our guaranteed time, not give everybody 1 hour, but basically to say, okay, we're going to answer a few questions together. And so we have a number of programs. One of them is on the protostars. That's the early stage of star and planet formation. That's the JWST program that I'm leading. And basically everybody who was part of the European consortium could sign up to these according to their interest, to these various groups. Another one is on the protoplanetary disks, where we are also investing a quite substantial amount.
So what brings you to the Vatican Observatory this week?
This week, it's multiple things. So first of all, we have a team meeting here of our JWST team. So in total, JWST is a relatively small consortium. I like that. I don't like these very big consortia, but this one is about 30 people, of which close to 20 were here at the Vatican Observatory, very kindly hosted.
So we basically turned over our
meeting
room to you guys.
Yes, yeah.
Right.
And so we had a very productive meeting here. Now half of that is also my group is coming here. So my group from Leiden and Garching is arriving here today. And then tomorrow and Friday we have another one, group meeting where we discuss sort of in a broad sense, not like you do when you're sitting in an office, but the broad sense, okay, what are the big questions we're tackling? What are going to be our big questions for the next year? And so that is going to be in the next 2 days. And then next week, both of us are going to be at the Pontifical Academy of Sciences, which has its biannual meeting there.
And which has a theme that connects both to Earth and astronomy.
Exactly. It's going to be the Anthropocene, how humans have actually affected, influenced what is the development of Earth. Yeah.
But we've invited a few outstanding astronomers to come and talk about that, to view the Earth from an astronomical point of view.
Yeah.
Among them, my friend David Grinspoon, who will be here.
I look very much forward to hearing him and meeting him. Yes.
Well, you had 2 days of a workshop, yesterday and the day before. Can you tell us what you know at the end of those 2 days about the JWST program that maybe you didn't know Monday morning? What came out of this workshop?
What came out of the workshop? Oh, as always, a lot of details, but I think we found a way forward that we didn't before we started, of how to quantify actually how much mass a young star, and especially its disk, is losing actually in the early stages while it's forming planets. So if you want to form planets, you need to do it quickly enough while the disk still has its gas around. And so there's always this balance between, on the one hand, the star is still forming, the star is still developing and accreting material. The disk is being fed, but at the same time, it's also losing mass. And I think we now found a way of measuring quantitatively that amount of mass.
So rather than just coming up with models like we did 50 years ago, wildly unconstrained by any data, you now are actually observing this happening.
Exactly.
And you can. One thing that astonishes me is the detail of the spectra that you are able to get. And describe a little bit what that tells you, how you make those measurements and what that tells you about these disks.
Yes. So one thing that was important, what you do as an astronomer in the early stages of a project, is that you need to set the instrument specifications. So how sharp does it need to that's the size of the telescope, basically. But then also what is not just the wavelength coverage, but also the spectral resolving power. How sharp can we see the lines? And there we insisted on higher spectral resolving power than NASA and ESA actually wanted to give to us. And now we're very happy because these spectra are chock full of lines of water. Water is one of my favorite molecules. I'm now completely drenched by it. We have a very wet few days here in Castel Gandolfo. So water is one of my favorite molecules, but also acetylene, HCN, lots of hydrocarbons actually, benzene even. We see these spectra actually full of organic molecules and water, molecules that actually are important if you want to build ultimately inhabitable Earth. I mean, you just don't, we're interested in building Earth, but we're also interested in making them habitable. And for that, you need water, you need organic material. And that is exactly what we are now measuring there.
Fabulous. The thing that I think is really exciting is seeing teams, that it's not you using this telescope, but there's a team of 30 people and you're dividing up the work in some way.
Yeah, that goes very naturally. So all young people, I mean, all the projects are led by PhD students or postdocs. I feel sort of myself more as a gardener trying to put everything in the right place, and making sure that they can blossom. And that is a wonderful feeling. But they very much are able. You know, you say, okay, once you have the data. So usually it doesn't work if you have rigidly planning everything in advance, because once you get the data, everything is different from what you expected. So what happens then is exactly like we're doing now, sitting together, just looking at the data and say, oh, there's that in that we hadn't realized. And then you come up with the project. So at the end of the day, yesterday, we had a spreadsheet of 50 projects and we were basically excited, assigning names to that.
So much of science, I mean, the stereotype of the scientist is the nerd who has no social skills, but it's just the opposite. We're the ones who work in teams. Yeah. We're the ones who have to be able to work together. The politics in the best sense of deciding somebody's got to do it, here's who's going to do it. Organizing all of that is an enormous part of what makes something like the web possible.
Absolutely. And you see that more and more indeed, some teams are more successful in that than others. And some of them are also more competitive than others, but there's so much good science that can be done with these telescopes that there's room for everybody to.
I sometimes mention to especially my non-scientist friends, when was the last time you saw a philosophy paper written by a team of people? Doesn't happen. Or when was the last time you saw a poem that had a co-author?
Yeah.
And then I mentioned, well, there was Lennon and McCartney.
Yeah,
and they seem to do a pretty good job. Maybe there should have been more of that. But the whole point I'm leading to is another job that you've had in the last 10 years, speaking of organizing the astronomers, these stray cats to all work together, which is in the International Astronomical Union. And you're the past president of the IAU. How in the world did that happen to you?
Exactly. Yeah, that was a wonderful period. How did it happen? It actually started with the then president, Bob Williams, contacting me in 2012 and saying, we're going to restructure the IAU completely. We're going to restructure different divisions. We have a new division on interstellar medium. And rather than having elections, we want, because it's all new, people cannot vote yet for the president, we want you to lead the interstellar medium division. I said, okay. As long as it's not too much work, then I can do it. So that was 2012 to 2015. And then just before I ended that, I got this letter and that, do you want to become the next president? The president-elect. And I said, okay, that is a whole other level. But by that time, I had seen enough already of the IAU. And I must say, my field, astrochemistry, really grew through the IAU. So I had been the secretary and then the chair of the working group on astrochemistry, and which had actually as its mission to bring astrochemists from across the world together. And we as a community had been very successful in that. And so I felt sort of the spirit of the IAU was very much what I liked. And then there was another thing that they, in the sort of the invitation, it said, and by the way, in the period that you will be president, that's also going to be 2019 is going to be the 100 years of the Astronomical Union. So we expect something special then. And I thought, okay, that's is interesting, but that's, you know, is also a huge opportunity to highlight everything that IAU is doing and that astronomy is doing actually across the world.
Because the IAU was really born out of the ashes of World War I.
Exactly, and out of the ashes of the Cartesian actually plays also a role.
The program that the Vatican Observatory.
Yeah, exactly. That played a role in it. So you're 3 years president-elect, and then you're 3 years president, and then you're 3 years past president. So I just stepped down as past president. So in total, it was sort of a 12-year commitment, but I enjoyed it incredibly.
It was, I think, 2019 when you had the celebration in Brussels of the 100th anniversary, the same week that the Event Horizon Telescope had the announcement of the new image of the black hole. So I was able to go to both of those.
Yes.
Because I happened to be in Brussels that same day. And of course, Heino Falke, who was involved in that, was a summer school student of ours back in 1993.
Yeah. No, we of course, when we were planning all of this, we wouldn't have known that the announcement was going to happen. Of the EHD image was going to happen in exactly that same week, the day before our celebration, and in Brussels. So it was a wonderful occasion. Of course, we got Heino then also as a speaker.
And the last organization I'd like you to talk about is the Pontifical Academy, because that's also another one of these international groups where people can get together. And of course, you don't have to be Catholic. You don't even have to be a believer. Stephen Hawking was a member. But it's a place where people can come and talk about the things we're madly in love with, which is the study of the universe. How did you get involved in the Pontifical Academy?
Well, that's a very good question. Actually, my first visit to the Pontifical Academy was in 1996 when there was one of these workshops on the origin of life. And I remember then coming there, and really it was an excellent program and really enjoying it. So then I didn't have any contact until 2020, I think, when I was invited to be, by that time it was Zoom, to be on the speaker at the plenary. I think Martin Rees had invited me as IAU president to give a presentation there on, it was basically on science and society, astronomy for a better world. And so I did that by Zoom, and then a year later I was invited to become a member. So
I outrank you since they made me a member back in 2015. but only ex officio. I only get to be on there as long as I've got the job. And then certainly where we wound up working together was last February.
Yeah.
Talk a little bit about what that event was.
Yeah. So one thing that also happened was that shortly after I was appointed, I was invited by the president actually to become also a member of the council of the Pontifical Academy of Sciences. And that's that is actually also organizing various more focused scientific workshops. Can be on quantum computers, can be on neuro technology. So lots of very interesting topics. And then that was just when Webb had been launched, and I was showing to the council, I was showing these first Webb images and the excitement that there was in the world. They said, okay, we should have a workshop on that. And so they invited me to come up with a proposal together with you. And then we made that proposal and we had a wonderful workshop.
And we had a great time. It was fabulous.
Absolutely, yeah.
Well, we're at sort of the 10-minute 2 point where we try to sort of wind down. But if people have questions that you'd like to ask Ewine, please feel free to type them into the chat. That's probably the easiest where I'll see them. I know that Bob has been really good at adding a lot of links to the topics we've been talking about. But anyone, if you have a question that you want to bring up, now's the time. And I don't see anybody typing massively. Wave at me if in fact you are typing a question. Other than that, I would just like to say thank you. Thank you for being part of this. Thank you for chatting with the people who are, tuned in here. And to recognize that the work of the Vatican Observatory is definitely interlinked with the international work of astronomers around the world. We all know each other. In some cases, we studied together. We know the people that, we know these different. I didn't even realize your connection to the planetary world and the planetary world at Caltech. Right? Some of my best enemies are there.
We have a couple questions, brother guy.
Okay. If you can read the questions then, Bob.
That would be good. That's good. Chris says Rob and Pam. And I don't see them.
Oh, sorry. I thought I saw you raise your hand. I believe Rob Lorenz was typing a question at some point.
There we go. Do gas giants form from the inside out or the outside in?
Oh, does gas giants form? Well, there are different theories, actually. This is actually, probably the answer is both. The standard theory is that you first form a rocky core, a little bit like the Earth, but probably 10 times the mass of the Earth. That's a slow process, but it needs to happen relatively fast, because once it is massive enough that it can sort of accrete the gas that is around it, then that needs to be happening fast. Then it is a runaway process, and then you basically make a gas giant like a Jupiter-like planet. That's what we think that the bulk of the giant exoplanets that we are observing is made through. But there is another one. We see some of these giant exoplanets very far from their parent star. And then this process is not so efficient. And there we actually think that in the very early phases, part of the disk can actually collapse on itself. And then it's more an outside-in effect.
From the observations, how can you tell the one from the other?
Yeah, exactly. Well, there's some very exciting ALMA observations just in the last months that hint at seeing for the first time this gravitational instability process in action, so to say. People have been moving a little bit too far towards the other camp, whereas the gravitational instability, basically collapsing part of the disk to form a giant planet, has always been on a viable path as well.
I remember the wonderful bit of literature, which is The Once and Future King, where Merlin tells young Wart, everything not forbidden is compulsory. If it can happen someplace in the universe, it probably is happening.
Exactly.
And so this could be what's going on with the giant planets.
Yeah.
Fabulous. Are there other questions?
Yes, we have. Are you finding that other planetary systems form consistently with our system or in a variety of different ways?
That's also a very good question that we are only just starting to address. So if you ask me what is one of the outcomes of this workshop and the one that we're going to have in the next 2 days, it's basically the diversity of planetary systems information that we see. Not two of them really look the same, and both chemically, but also physically. And so that is one of the, basically the challenges that we now have, that where does this diversity come from? Is it set by one giant planet forming very early and putting in roadblocks basically in the disk for that material can no longer move in the disk? It's just a whole variety of things that we are learning at this very moment from the combination of both ALMA and JWST.
And I see one other question. What do you learn from the red shifts or the blue shifts of these lines?
Yeah, that's because that is indeed something we can measure, and we can measure that exquisitely with ALMA. We can measure it to a somewhat smaller degree from Webb. One thing we can see is the outflowing gas. As all these young stars have jets. We talked a lot about jets at our meeting in the last 2 days. Beautifully imaged by Webb, and we see the material going at very high speeds, 100 kilometers per second or more.
And you can measure that with, these lines.
With these lines, both the red shifted, the part that's moving away from us, and the part that is coming towards us, which is blue shifted. So we can measure that from the shape of our spectral lines. Yes.
Okay, are there any other questions that you saw there, Bob?
No, I think you got them.
Okay, well, thank you once again. Thank you for your time. Thanks everybody for participating here, and we'll see you the next full moon.
Thank you. Thank you for
Take care,
attending.
everybody.
Thank you.
Bye, everyone.
All right, thank you, Bob. I can't hear you.
Hi. Okay, unless you want to stay on.